So we're doing a proof by induction here. This time we're going to be proving divisibility. Now, best just to look at an example so you can see exactly what we mean by that. We're going to prove that 9 to the n minus 1 is divisible by 8. Now, I'm going to do this the way that most people do it. I know I've been saying I do this backwards, but I'm going to do this, start by testing the base case. Test base case. Alright, so I'm just going to test to see if this works with n is equal to 1. So, n equals 1. That's going to be 9 to the 1 minus 1, and that's going to equal 8. 8 is divisible by 8. Yes. I might just test one more. This is not part of the proof, so I might just do it down here. But if n was equal to 2, then we'd have 9 to the 2, which is 81. Subtract 1, 81 minus 1, 80. 80 is also divisible by 8. Alright, I'm pretty comfortable here. I've got 2 test cases now, but you only need to do 1. Now let's figure out how to prove this. So we're going to do our induction step. And our induction step is to assume that this works for k. Assume 9n minus 1 is divisible by 8 for n equals k. Now, if that's true, and this is kind of an important step, if that's true, then 9n minus 1 is equal to 8n. Now, what we mean by that is m is an integer, so m is in the natural numbers. 9n minus 1 is going to be equal to 8m. This is equal to 8 times 1, this is equal to 8 times 10, the next one will be equal to 80 times something. But if something's divisible by 8, then it's going to be equal to 8m. If it's divisible by 3, then 3m, etc., etc. Now your next step is to prove, given true for k, also true for k plus 1. Now we're not going to do our left hand side, right hand side like we did last time, but it's a similar idea. So if 9 to the n minus 1 equals 8m, then 9 to the k plus 1 minus 1. Now stop there. The game starts now. What you need to do is make this into something that's divisible by 8. So this can be rewritten as 9 times 9k. So that's our reverse of an index law here. We're saying 9 to the k plus 1 is equal to 9 times 9k. And then there's a little minus 1 here on the end. Now, at each juncture here, at each step, take a look back to your original and say, that should be a k here, shouldn't it? Take a look back to your original and say, can I substitute this into this? Well, if I rearrange this a little bit, I'll have 9k is equal to 8m plus 1. Alright, so I can sub in 9k equals 8m plus 1. So that's going to be equal to 9 bracket 8m plus 1 minus 1. I can expand my brackets here and get 72m plus 9 minus 1. And now 72m plus 8. Now this is a divisibility proof, and I'm trying to prove that it's divisible by 8. And it's divisible by 8 if I'm multiplying something by 8. I can factorize this with 8 as a common factor. Alright, stop there. Take a look at this. We said that 9k minus 1 is equal to 8m, and we've just assumed that. And we've said, prove, given that that assumption is true, that k plus 1 also works. We've just done that by assuming that 8m plus 1 is equal to 9k, which we got from here. We found that this is now divisible by 8. So k is divisible by 8, k plus 1 is divisible by 8, our base case was divisible by 8. The proof is complete. You can go QED if you want to. Alright, so stepping back, test your base case. Your induction step is to assume that it's going to be divisible by 8, and so we rewrite it as 9k minus 1, whatever it is that we're trying to prove, equals the divisibility factor, 8 or 3 or whatever, m. And then we start working, and we work at looking for two different things. We work at looking for an opportunity to sub in some form of this into this, and then we work through it looking for an opportunity to factorize. The last thing I'll say here is that it's important to understand that the thing in the brackets here has to be a whole number. If it's not a whole number, then this doesn't work. But luckily for us, we know that m was a natural number. That was one of our assumptions in the beginning. We probably should have written it here. M is in the set of natural numbers. That's it. Good luck. These ones are tough.